Well, the objective of this demonstration is to talk about some random numbers in Python. So there are several ways to work with the random numbers in Python. There is one with the built-in random library. So for that case, we don't have to import any other library. We say import random, and I can say random I haven't called any function from the library. I have to say random dot rand. This is the default library available in Python. Yes. So a random number has been generated, and it is written with the 16 digits in the double precision format. Yes, it has utilized a rule. Basically, they take the starting point at the time of the clock. So you can see the base algorithm for it. So it will give you one random number at a time. But we generally use the other library. Well, there are other functions as well. You can look from the Python documentation. But I'm more used to with the numpy library. I say numpy as np, and also I import the plot library, matplot.lib.py plot as np, because I have objective to show the distribution of random numbers. So now let's work with the numpy dot random library. So I say numpy random dot random. So it is similar to the random dot random library. So one random number has been generated, but the random library numpy random dot random pi. So it will create a vector of 5 random numbers. Can you pick up the sequence? Is it arithmetic sequence, geometric sequence, harmonic sequence? So it's very difficult. It's very difficult. Please test it. Please test it at your home. If I repeat this calculation, so let me write this one, the same command here. So you will find that a different set of random numbers have been generated. Right? Yes, so it will give. Now let's check whether the numbers are uniform or not. So I have let's devise a simple test that let's check 50-50 distribution about 0.5, right? So random numbers are between 0 and 1. So let's check. So for example, now I take say n equal to 100, right? And I count. So I say I count equals 0, and I say for jj in range n. So generate n random numbers, not in a vector. It's all up to you to store them in a vector or not. So generate the number, and let's store the number numpy dot random. So generate one random number and check. Now check if x is less than or equal to 0.5, right? So I count is equal to I count plus 1. So I can say here plus equals 1. What is the meaning of this statement? It has a meaning in convention that update the count by 1 or increase. This statement can be written uh, in Python as this. It means whatsoever the previous value of I count is, add 1 to that. And that's it. So at this stage, I say the end of if statement and then set end of for statement. And now let's print the value of I count. I count equals I count. So I have taken 100 random numbers. I have not generated an array. I have generated the random number one by one, right? So my program remains efficient. There is error, syntax error, okay. There is that. I count, okay. So in print statement, the two variables must be separated by a comma. 52. So 52 random numbers are less than 0.5 and 48 are greater than that. So let's check for 1000. 493. Yes. 10,000. 4982. But it seems to be equivalent that half of the numbers are less than 0.5 and half are greater than 0.5. Let's repeat the same calculation and see the number. This number is same. It means because the sequence of random numbers or the random numbers generated this time, they have been changed. Right? Well, it is not going to survive. It is going to be floating. First time it was 52. 50, right? So it is changing. So it has the property of generation of the random numbers. But I see this check with this suspicion. I have a strong belief that this property is also going to prevail for normal distribution. A normal distribution do not contains the shape, the uniform shape. It has a peak, but 50% numbers are less than the middle value and 50% are greater than the mean value. Instead, for normal distribution, I can say here random dot rand m. So this is the normal distribution random number. I will make it clear after some time. Okay. So I think this test is not adequate.